Okay, we're still in the atomic structure unit, and this is a review of isotopes. Now, I say that word a lot, and I want to make sure that you know what an isotope is. An isotope are atoms that have the same number of protons, but they have a different number of neutrons. So their atomic number is the same, but their mass number is different because they have different numbers of neutrons. So I've heard people say that an isotope is just two different forms, or it could be 3 or 4 or more forms of the same element. They just have different masses because their number of neutrons is different. But that atomic number stays the same. The number of protons does not change. So let's look at an example of two isotopes of phosphorus. We have P32 and P31. This, again, remember, that is our mass number, not on the periodic table. If we did go to the periodic table, we would find the atomic number 15. So sometimes I like to put that down here. And sometimes it's already there for you. All right, mass number is 32. That's protons and neutrons. 15 is our atomic number of protons. Okay, this is still phosphorus. Okay, it's an isotope. These are isotopes of one another, but it has the same atomic number. It's phosphorus. It's atomic number 15. What's different is the mass numbers, 32 and 31. All right, how many protons in P32? Oh, we have 15. And we have the same number of protons in this isotope of phosphorus. How do we get neutrons again? Well, 32 minus 15 is equal to our number of neutrons. And so that equals 17. Remember, we can check if we did it right. Adding the neutrons and protons together should give us the mass number. In P31, notice the mass number is 31, the atomic number is 15. 31 minus 15 gives us 16 neutrons. Double check. Neutrons, protons should equal the mass number, and it does. All right, let's look at this carefully. The protons are the same. The neutron number is different. That's what gives it the different mass number. That's isotopes. Okay, here's another element, iodine, with two isotopes. We have iodine 125 and iodine 123. Mass number right here. 125 and 123. Go to the periodic table, find the atomic number. It's 53. How many protons in iodine 125? Well, the number of protons is your atomic number, 53. How do we get those neutrons again? It's the mass number minus the protons. And so that gives me 72 neutrons. Add them together, do you get 125? We're good. All right, another isotope of iodine is iodine 123. It's still iodine. The atomic number is still 53. That doesn't change. Remember, isotopes have the same number of protons. The atomic number is the same. Boom, the same. The number of neutrons is going to be different. 123 minus 53 is equal to 70. Notice the number of neutrons are different. That's what makes them isotopes. The neutrons are different, but the protons are the same. So I hope you've got this concept of isotopes. Now, let's move on to looking at the atomic mass. Now, this is what is on the periodic table. It's below the symbol. And it's the weighted average of all the naturally occurring isotopes. So let's have a look at this. Copper has two naturally occurring isotopes, copper 63 and copper 65. So here are the isotopes. They will give you the percent abundance data. 69.15% of it is copper 63, so the majority of it is copper 63, and the remaining 30.85% of it is copper 65. So now we have our two isotopes. They're both copper, same number of protons, different mass number, okay? And here's the isotope's mass. So copper 63, sometimes they just use the mass number, but we're looking at the exact data here. 62.929 atomic mass units. and copper 65 is 64.927 atomic mass units. With all of this information, we're going to calculate the atomic mass, the weighted average of all the isotopes. You know, this copper is going to count a little more. The copper 63, there's more of it, it's going to count more. So let's see how we do that in a calculation. All right, with this data, we are going to calculate the atomic mass of copper. So here we go. Now, our percent abundance, we're going to have to change a little bit. We're going to put that percentage into decimal form. So remember, it was 69.15% copper 63. We take that percent and divide it by 100, and that'll give us the decimal form. You'll move the decimal to the left too. You really don't need a calculator to do that. You take the percent abundance and you multiply it by that isotope's mass. All right, let's go to our second isotope. It was 30.85% abundant. Again, to those percent abundances, divide by 100. So we get 0.3085, and we're going to multiply it by that isotope's mass of 64.927. Okay, you multiply this times this, and then you add to that this times this. And when you add that up, you get 63.55 atomic mass units as the atomic mass of copper. I really think you should try this on your calculator to make sure you're using your calculator the right way. Again, divide your percent abundances by 100 and multiply the percent abundance by the isotope. And you do that for every isotope. We could have 22 isotopes, and you would do this 22 times. Add them together, and that is your atomic mass. This is what's on the periodic table. Let's have a look and see how we did. Let's look at our periodic table up here. Hey, 63.55. We got it right. Again, this number down here, it's not the mass number, it's what we call the atomic mass, and it's the weighted average of all the isotopes. Again, up here was our atomic number, our number of protons. We have more practice that you can do to calculate the atomic mass of different elements. So we'll give you a sheet on that to practice. So this ends our atomic structure unit, and I hope all of these review videos have really helped you learn all this material, and you can do really well on your test.